Assalamualaikum warahmatullahi wabarakatuh, and a very good day to Dr. Shrina Abdullah. We are from Group 6. We represent the experiment continuous third reaction. Now we present the abstract. My name is Nurhuda Ifa Betirusnan, and my ID number is KH223. In this experiment, saponification reaction of ethyl acetate and sodium hydroxide is studied experimentally in continuous third tank reactor, which is CTR. The effect of temperature and the reaction time to determine the relationship between conversion, conductivity, and time. After 0.1 molarity sodium hydroxide is filled in 3 tanks, and will undergo the process with a tank of 0.1 molarity of ethyl acetate. The data is taken for every 2 minutes till it reached the steady state, and the data of conductivity temperature was recorded. All the result is being recorded. Thus, calculation is made, and the graph will plotted based on the data and the result. By the graph, the rate of reaction can be determined for this experiment. Thank you.
Hi everyone, I am Nur Fazana bint Yusuf. My ID number is KH20031. Okay, for my part, I will present about the methodology of this experiment. Okay, first, we need to do the preparation of calibration curve. And second, we need to do the saponification of Cstr in series. Okay, how we conduct the preparation of calibration curve. Okay, so first, we must prepare 1 liter of 0.1 concentration sodium hydroxide and 1 liter of 0.1 concentration ethyl acetate. Then we do the preparation for these 5 solution, and we mix them into 100 milliliter of the ionized water. So next, we got the conductivity for each conversion value, and we do the calibration curve of conversion versus conductivity. After that, we also got the value of slope and y-intercept from this calibration curve. Okay, next for the saponification of Cstr in series. Okay, how we conduct this saponification? Okay, first we pour 10 liter of 0.1 concentration ethyl acetate into T1, and also we pour 10 liter of 0.1 concentration sodium hydroxide into tank T2. Next, the valve. Next, we open the valve V3, V4, and also V5, and also we switch on the pumps P1 and also P2. After that, the valve, the lever valves V3 and V4 are adjusted to obtain flow rate 100 milliliter per minute. Okay, then the liquids fill up to all 3 reactors. After that, we switch on the stirrers 1, 2, and 3, and we set up at 200 RPM. Then we start the timing. After that, the conductivity value for CT1, CT2, CT3, and temperature TT1, TT2, TT3 are recorded every 2 minutes. After the timing stop, we record all the time and conductivity value. After that, we repeat all the steps 6 to 9 from this until this by change the flow rate to 150 milliliter per minute. That's all. Thank you.
Good morning. My name is Samuel. Then KH20018. Now I'm going to explain about result and discussion part calibration curve. As you can see, this is our calibration curve table data. The conductivity and also the concentration and the conversion rate, where we have used for 0% of conversion 100 ml of sodium hydroxide and also water. And it will, once the conversation rate increases, the volume of each sodium hydroxide decreases by 25 ml. As for water, we have a constant rate of the volume. This is our conductivity rate, and this is our graph for conversion versus conductivity. As you can see that when the conversion rate decreases, the conductivity rate increases. As you can see that figure 1 shows the calibration curve of various conversion versus the conductivity. We can derive as conversion rate decreases, then the conductivity increases. This graph shows the theoretical value and relationship between the conversion and conductivity. Following that, a graph conversion was created using data from table 1, and it is possible to conclude that the graph 10 is decreasing over time as shown on the graph, and the slope of that graph is negative 0.1414, and the y-intercept is 2.2675. Thank you. And I'll pass it over to Anas to explain about the conditions and also the further part of the data and discussion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Anas bin Ahmad Sabaruddin. Metric number KH20051. So today for this experiment CSTR, I will discuss about result and discussion. So for condition 1, we use 0.1 molar ethyl acetate and 0.1 molar sodium hydroxide. And the flow rate we adjusted to 100 milliliter over minute, and the stir speed to 200 RPM. And this is the result that we got from the experiment. We used from 0 to 24 minutes to get the overall experiment to the end for the condition 1. So what we got is conductivity T1, T2, and T3. So for the conversion, we have to use calibration curve to get the conversion for each minute. Then is condition 2. We still use 0.1 molar ethyl acetate and 0.1 molar sodium hydroxide, but we change the flow rate to 150 milliliter over minute and use the same stir speed to 100 RPM. And this is the result that we got. So next is the graph. So graph 2 is the conductivity versus time for condition 1. And this is graph 3, conversion versus time for condition 1. Okay, for the experiment was carried out to perform saponification reaction between ethyl acetate and sodium hydroxide in the Cstr to determine the effect of reactant flow rate in this reaction. In this experiment, the first step, we filled tank 1 with 15 liters of sodium hydroxide and 15 liters of ethyl acetate in tank 2. The pump 1 was turned on to fill in the reactor with sodium hydroxide first. When all of the 3 reactor Cstr was fully loaded with sodium hydroxide, the initial conductivity was taken. After that, the pump 2 was opened to start the reaction of ethyl acetate with sodium hydroxide to produce sodium acetate. So for condition 1, the flow rate we adjusted to 100 milliliter over minute, and for every 2 minutes, the reading of conductivity was taken until 24 minutes. Graph of conductivity versus time was plotted, and based on the graph, we can conclude the conductivity was decreased with the time. Conductivity reactor 3 is lower than conductivity reactor 1 and reactor 2. Conductivity reactor 2 is higher than conductivity reactor 1 and reactor 3. So the graph of calibration curve was taken to get the conversion of sodium hydroxide. So based on the graph 3, the value of conversion reactor 3 is higher than reactor 1 and reactor 2 because mostly the ion of sodium hydroxide was formed become sodium acetate. So the conversion of reactor 1 is higher than reactor 2 because the ethyl acetate is the first one that fill in the reactor from reactor 1. So the reaction is begun first. So next is graph 4. Is the conductivity versus time for condition 2. And next is graph 5 is conversion versus time for condition 2. So for condition 2, the experiment was repeated with flow rates be adjusted to 150 milliliter over minute. So in theoretically, when the flow rate are increased, the conversion will decrease to shorter residence time. But based on graph 5, we can see the graph that we're supposed to get is conversion decrease as the time increase, but the result is the that we obtain from the experiment at time 18 to 24 minutes, the conversion still increase, then constant at the end of experiment for condition 2, which is the flow rate is higher than condition 1. So from the observation, the value obtained does not fit the theoretical theory for the experiment. We can assume that during conducting the experiment, that some error must have occurred. So we can say that the result also depends on the temperature, because for the condition 1, at the flow rate 100 milliliter over minute, the temperature was at 20 to 25 degrees Celsius, but the condition 2, the flow rate 150 milliliter over minute, the temperature was at 25 to 26 degrees Celsius, which is higher than condition 1. So based on the Arrhenius equation, when the temperature increase, generally the reaction speeds up the process because the rate constant increase according to Arrhenius equation. This is the Arrhenius equation, K equal to AE negative EA over RT. So that's all from me. Thank you very much. Assalamualaikum.
Now I'm going to explain about the advantages of CSTR versus other reactors, which is batch and PFR. As you can see, for CSTR, it is continuous operation, can be used for small and large scale of products. It is easy to clean. It has good temperature control, and it can easily adapt to two-phase runs. Where you can see for batch reactor, it gives high conversion since it is a closed system. It has a good for producing small scales of product. It is easy to clean, which is same to CSTR. It has a low contamination risk since the reactors are in the closed conditions, and it is suitable for reaction that requires long reaction times. As for PFR, it is also a continuous operation compared with CSTR, and it is far mostly used for large scale of products, high conversion per unit volume. It is also a good heat transfer, and its cost is low. That's all we can see for advantages of CSTR compared to others. Now we are going to go to application of CSTR in chemical processes and industries. We can see primarily application of CSTR is used in wastewater treatment processes. Secondly, for loop reactors in pharmaceutical industries, and fermenters, which involves use of biological catalysts such as brewing and hydrocarbon processing. That's all from me. Thank you.
Assalamualaikum, my name is Nuruzna binti Muhammad Karimpa, my matric number KH20072. Okay, I will continue for the part of conclusion. As the conclusion, the continuous stir tank reactor or CSTR, which is primarily used for liquid phase reaction, is a common type of reactor used in industrial processing. It is normally operate at steady state with assumption that it is perfectly mixed. The conductivity calibration curve is shown in this slide, which made with different molar concentration of sodium hydroxide and ethyl acetate. This calibration curve can be used to calculate the concentration of sodium hydroxide and their conversion for condition 1 and condition 2. Based on the graph 3, 4, 5, and 6, we can conclude that when time increases, the conductivity decreases. Meanwhile, the conversion increases until it constant at one point. We also can say that when flow rate increase, the conversion also increase, as shown in graph 4 and 6. But it is also depend on the temperature. High temperature will give a higher conversion. Okay, for the precaution and recommendation, okay, for precaution step, pour the ethyl acetate at open area because its odor can make we feel dizzy. It has such a strong odor. Okay, next, wash the Cstr tank and reactor before and after using it to ensure that no impurities will disturb the data we will obtain. We also need to wear goggles before pour the solution into the tank because our eyes might be splashed with it since the tank is placed higher. Lastly, do prepare an extra solution for this experiment to avoid error in our data. The recommendation for future works are replace the motor steerer with the digital motor steerer so that we can set up the speed easily. Next, provide bigger beaker. Since we use a large volume for this experiment, so we need a large beaker. Lastly, provide more measuring balance in the lab to minimize the time of student to prepare the solution. Thank you.